Good morning, good afternoon, ladies and gentlemen. Welcome everyone to this online session where we talk about fireproofing your lithium-ion battery assets. As you know, lithium-ion does have a tendency, or sometimes it has fire issues. And although these have been far between, they do happen. But there are a number of strategies and procedures that you can follow in order to minimize those incidents and to make sure that your assets are as fireproof and as fire resistant as possible. And this is what we're here to talk about today. My name is Belén Gallego, and I am from the ATA Insights team. We bring you these webinars, but we also bring you events, as you know, around the world that talk about storage and hydrogen mainly. And we're actually putting together this webinar as like a warm-up for an event that we're holding in March 29th and 30th in Spain, in Toledo, where we're going to be talking about storage in the Iberian Peninsula. So if you are interested in that, we will send you information later anyhow. But for now, we're going to go straight into this topic, and I'm going to introduce you, first of all, the three expert speakers you're going to be hearing from today, so that you can get to know them a little bit better if you don't already, and then we will take it from there. So first, I'd like to ask Charlie to please introduce yourself so that people in the audience may get to know you a bit better.
Yes, hello and good morning to you all. I'm Charley Grimston. I'm the executive chairman of a company called Lithium-ion, and we are a specialist battery and energy risk consultant. We're a specialist battery insurer, and fire and explosion are very much part of our everyday life. I've personally been involved in the insurance industry for quite a long time, quite a few decades, and always been involved in innovative and new technologies and finding ways of resolving problems that arise globally.
Thank you, Charlie. I didn't want to be quite so strict, but the truth is, this is an issue that we all need to face and realize, just how important it is. So you're going to hear from Charlie. Next, I would like to ask Carlos to please introduce yourself so that people can get to know you. Go ahead.
Thank you, Belén, and thank you for inviting Saft to this webinar. It's a pleasure to be here. So my name is Carlos González. I am the sales manager for energy storage within Saft for South Europe. And today we will be talking from the fire safety from a manufacturer's and construction point of view. Saft is delivering turnkey solutions from the battery containers and also the converter and the control. So I will explain a little bit what is the safety features and the impact around the system and how to mitigate the risk.
Excellent. Thank you very much, Carlos. And I'd also like to ask Jordan to please introduce yourself.
Yeah, thank you, Belén. Hello, good morning, everyone. So I'm Jordan, sales representative from the French company Stif, and we are going to see with Stif two special cases today of fire and explosion protection. But in Stif, we are specializing in manufacturing safety equipment for battery energy storage system. So we are going to see after what could be the solutions for BESS. Yeah.
Excellent. Thank you very much. So now you know Charlie, you know Carlos, and you know Jordan, and you know that you're going to get like first-hand and first-class information. I'd just like to do a little bit of housekeeping before we begin, okay, so that you all know what you have to do. So if you're on Zoom with us, and I can see there's quite a few of you here, then please what I'll ask you is first, use the chat to introduce yourselves. Please, you've been really shy this morning. Usually people are a lot quicker, to take onto the chat, introduce yourselves. Usually I say use your name, use your company, and also where you're joining from. And we love to see, the speakers here love to see, how many countries you represent. So, welcome everyone, and please introduce yourselves. Tag everyone so that everyone can see you, okay? In terms of the questions, obviously we always prepare a little bit of a structure, and the structure today is you're going to have 3 presentations, and then after we're going to have a turn for Q&A, hopefully as much time as we can possibly gather. However, even though we have questions, we'd like to hear your questions. This is an opportunity to ask these three super experts, your questions. To do that, you use the Q&A box, which is at the bottom of the screen, okay? You can send them through there, and our speakers often, they monitor them, and if they can answer some by text, they do that as well. So please do that. If you're on YouTube, what you have to do is just use the chat, just send it your question, and, both myself and my tech deck will be taking a look at that and bringing them into the Zoom room, okay? All right, okay, now, without further ado, reminding everyone that the materials that you're going to see on screen and the recordings will be available for you to take a look at, to share with your colleagues, okay? So don't worry, we will, as always, send you all of the information that you require. So without further ado, I'd like to invite Charlie to please take your mute off, share your screen, and let's start with your presentation. And I can see that now people in the chat are getting a little bit more, happy. And I can see we have people from Germany, from Tunisia, from Italy, from Canada. So some early risers there, New York, Spain, of course. So welcome, Denmark. Wow. It's really interesting to see, that this sessions is so international. There is a lot that we can learn from one another. South Africa. How's it going, Charlie?
Technical problem, but I'll solve that.
Don't worry. So, I can see also there are some old friends in here. I'm expecting really good questions today, I have to tell you guys. Because we have some people here that come to some of our webinars. Yeah, the UAE, Chile. You guys are on fire, and you're here very early. So, Charlie, perhaps we can give you a hand. Would you like me to remind you how to do it?
No, I've just got a technical problem, which wasn't apparent this morning.
It happens, doesn't it?
Yeah.
Another option is we can always get one of your colleagues to present first, if you like.
Yeah, why don't we do that while we just solve this technical problem?
Sure, let's do that. So bear in mind that, you're going to hear all about the risk side of things, but now I'm going to ask Carlos, you were the next up. Do you mind going whilst Charlie resolves his problem?
Absolutely, Glenn. So let me know when you see my screen.
We can see your screen and we can hear you, so go right ahead.
Okay, perfect. So good morning, everyone, again. So as the topic of today's webinar is linked to fire safety and how to protect the assets, I will briefly explain the safety from a manufacturer's and constructor point of view. First of all, what is our role? What is Saft roles in energy storage? So we, on top of supplying the complete turnkey solutions for our energy storage plant, we have been doing this for almost 20 years now. And in terms of the battery, which is the center element of these systems, we have over 100 years experience in manufacturing different electrochemistry. So we have our share of expertise in this area. When we talk about energy storage, we talk about, in particular about the battery containers, which have inside the battery cells, group into modules, unit or racks, and then this will be placed inside of the container. The container will also have the fire safety systems, which I will explain later, and also the control room to monitor everything what's happening inside of the container and also to control it remotely. So, which are the main risk in an energy storage system? So, the most famous one is thermal runaway, which is the rapid and controlled release of heat from the battery cell. And this is a topic that we will discuss quite a lot today. There are other risks inside of energy storage systems, like stranded energy, which is energy, electricity that still remains inside of the battery container and cannot be discharged well, while can mean a danger to firefighters or personnel at site. We also have toxic and flammable gases, that are can be generated when we have thermal runaway or a fire, and can also cause explosions. We have deep-seated fires. So battery cells, modules, racks, and containers are basically enclosures that, in case of a fire, is not allowing the water to reach this the seat of the fire. So that is an additional risk in the battery storage systems. And of course, and finally, we have any electrical risk, as for we can have in any electrical installation in any product or plant. So thermal runaway. When lithium-ion cell reaches a high temperature, exothermic reactions start to occur, and this may lead into a thermal runaway situation. A thermal runaway of a lithium system is a change of reactions, which is each one of them is triggered by a source of heat and triggering a next reaction in temperature. So what actually was happening is that if we have a defect on a cell or a high temperature on a cell, this can increase its temperature and then increase the temperature on the nearby cell, on the module, and start a change of reaction, which is very fast and can cause quick fires and even explosions. So at the end, the final risk behind this thermal runaway and the other risk that we have shown is fires that are well known in the media on battery storage sites that have been burning for several days, explosions, and hazard to people. So the safety objectives are, first of all, obviously, to protect the people, and all the safety barriers that we can introduce and the market can introduce in the energy storage project have their first target to protect the people. Secondly, to avoid damage to the equipment and other nearby equipment or buildings. And of course, finally, protecting an environment, as we are talking about chemical reactions, fumes, which can be very, very toxic. So in terms of the design of an energy storage system, we have different layers, and we can go to the components, we can go to the container level, and we can go also at safety measures to the site. The first relies on the battery cell, on how we design the cell, but also very important how the cells, the battery cells, are insulated between each other. So the target here is to know if we have a thermal runaway or an issue in a cell, that we reduce or avoid this cell propagating and activating the cell nearby and causing this thermal runaway reaction in all the cells and the modules. So this is one of the first step to avoid fire issues at site. So in the core of the design. There is the most known standard globally is the UL 9540A, which is the standard market practice for these systems, which will you can do it at a cell level, you can do it also a module, a unit, and an installation level. And at the end, what this test is looking for is to see if there is can go a thermal runaway, and also what is the fire and explosion hazard characteristics. I'm not going to go into details about this because this can be for another complete webinar, but this I would say this is the market minimum practice, and which is requested in most of the markets. Now going into Saft design, Saft energy storage design. Well, in Saft, we consider ourselves being market leaders in terms of safety. It's one of the pillars of the company, and I believe we are probably the only one in having 5 safety layers in our container. So here you can see how our container, which will you will see that this is not the structure can be similar to other systems that you will see, You'll see typically containers that are 20 or 40 foot, which will have the modules, the racks, and they will have some safety systems inside and also the control. The first important device element in the container is the cooling system, which is not only reducing the temperature inside of the container, but is removing the humidity inside. So with this, the cooling system, we are reducing the risk of an electrical short circuit because of humidity. Then we have as a first fire responder the gas suppression system, which is this bottle in red, which how it works is that when the system detects a fault, it will introduce nitrogen or other element inside of the container, removing and displacing the oxygen inside of the container, and therefore reducing the chance of having a fire. Unfortunately, this is not going to protect every single cases, but it will reduce a lot the chance of having a fire. Then we have the overpressure valve, which is the number 7, which if there has been a thermal runaway or a fire or increase of temperature or release of gases inside, there will be an increase of the pressure inside of the container. And this overpressure valve, what it's doing is releasing the gases to the top part of the container. So we avoid gases going to people that are nearby, we protect the people here. And secondly, we are also reducing the pressure inside and reducing the temperature. So at the end, reducing a possibility of an explosion or increasing the chance of a bigger thermal runaway. In case the gas has not been enough, we can activate the water FSS, which has water sprinklers directed to each of the modules to assure the reduction of the temperature individually. As I was mentioning before, it's very difficult to reach for the water to reach the modules and the cells from the outside of the container because there are many layers and enclosures. So this is the way that we are reaching the separate modules and assure that we will reduce the temperature individually. We have a water drain to remove the water inside of the container and reduce the chance of creating hydrogen gases by hydrolysis. Then we have the blast panels in number 6, which would mechanically open in case of a rapid increase of pressure, avoiding disclosure of the container and directing the gases and the flames to the top part of the container. So here we are also trying to protect people that are nearby, of course, but at the same time, we are avoiding that the pressure, the gases, the heat, and the flames are directed to equipment that are nearby. So we assume the loss of the container, but we protect the equipment nearby. And the last safety layer is a 10 centimeter isolation that we have around the container, 10 centimeter root wall, that what is doing is also preventing the flames and the heat get outside of the container. And here the target is especially to give time to the fire responders to reach the site, because at the end, the success of stopping a fire in a container is all about time of reaction and time of response. So we have seen which devices we have inside of a container, but the brain and how this is controlled is the most important element here. So inside of the container, we have spread dozens of temperature sensors. We have smoke detectors. We have CO detectors. We are monitoring the voltage inside of the cells, and all this information is sent and can be seen remotely through the cloud. So you can monitor the status of the equipment, and if there is any alarm in the system, you will be able to see it remotely. And very importantly, if the system detects a fault, like in voltage anomaly, high temperature, the system will automatically activate the circuit breaker and in a second step, if there is a detection of fire, so smoke or CO, this will automatically trigger the gas suppression system. At the end, all what we are trying to prevent is seeing ourselves in situations like the ones that you can see here that are widely known in the market, and unfortunately today they are still frequent, and all the industry, or most of it, is trying to work and to reduce, because at the end this is a problem of fire safety. It's a problem also of protecting your assets, but it's also a problem of image. And if for the renewable market and the energy storage market to be increasingly deployed, we also need the support of the media and in general of the people. So it's important that we protect our industry. And all these incidents that you can see here, they could have been avoided if some of the safety devices that are known in the market would have been deployed. Now I have finished with the product part, and I will briefly explain about the construction part. So we have gone through the safety systems in the container, and also on how to control it. But it's also very important how we deploy the systems at the site. It's important what is the distance between each container. We calculate this by doing tests and thermal studies on how the flames will be directed outside of the container, so we can know at which distance is safe to deploy the other container. In this scenario, that if we have an uncontrolled fire in one of the containers, we are removing or reducing the risk of this fire propagating to the nearby containers. So on top of this, we are also going to which buildings are built nearby, which can be dangerous for the people in them, but also can present an increased hazard to the site. So we also have to be very cautious and studying where the project is located, where, if it's in a residential area, what are the smoke and the fumes that can be released to the atmosphere, and also what is the available water in the site, so we can the site or nearby, so we can activate the secondary fire suppression system in case of need. And the last topic about the construction, and which is probably the most important, is the training. It's very important to train the firefighters so they know how to react in a technology that is often quite new to the markets, and to train the personnel outside. We have seen that many of these issues outside could have been stopped if adequate training and following of safety procedures should have been performed. So with this, I finish my presentation of today. As Belén was saying before, please feel free to make any questions, and we will gladly answer them today. Thank you.
Thank you very much, Carlos, for this great presentation, and thank you also for jumping in. You know, I know that you were supposed to go next. You do have a bunch of questions already, very specific in there. Some of them you may be able to answer by text. And so next I'm going to put back Charlie, see if we can make it work this time. Oh, there we go. See, you're flying through it now. You can just put this in like a large screen now. And I'm going to ask you, Charlie, to unmute once that, okay, now we can see the presentation. Can you take your mute off so that we can hear you? Here we go. No, we cannot. Can you unmute, please? Oh, now we can. We can see your presentation. We can hear you. Yes. So go ahead.
Perfect. Thank you very much. So let me explain about Altilium. We are a specialist battery insurer and energy risk consultant, and we rely on real-time battery data to manage the portfolio of business that we have. As a result, we've been able to develop specialist battery insurance products, which are designed to make batteries more bankable. We have academic links to 3 universities for battery research and development and cell testing. And one of our founders is concurrently the senior professor of energy at Lancaster and Duisburg. We provide consultancy to banks on fast safety of BESS at an OEM level. We provide consultancy to banks on the management of residual value risk. And we provide consultancy to OEMs on their fire risk. In a bit more detail, our specialist real-time data-driven insurance products are extended warranty on first and second life BESS, prolonging the useful life of batteries to 20 plus years, and closing the gap on the circular economy. Other products are extended warranty on electric vehicles, all risks for construction of BESS, and all risks for the operation of the BESS once commissioned. We also provide battery health as a service products. This is a slide here to give you a feel for the amount of incidents that have occurred. There are very few data centers of excellence in this area, and due to the different methodology they use, they have differing results. But we have chosen here the most conservative results from each of the areas that we have contacts with. If you go to the media, you will find the numbers are significantly greater. But I think the conclusion from looking at this is plain to see that fire and explosion is a risk. And on our estimates, about 2% of the deployed gigawatt hours per annum are involved in fire and explosion. And it's the consequences that you can see which are devastating. And there's one particular country that has the worst record. And this is primarily attributed to an inadequate design of the electrical protection system, inadequate control of the operating environment within the system enclosures, and careless installation practices that degraded the system's integrity. And lastly, inadequate energy storage system control and protection. So constant mold, voltage, noise in combination with humidity. I think it's also quite interesting to discover in the micro mobility sector, that's the e-scooters and e-bikes, there are very large volumes of vapor cloud prior to ignition, and that's up to 6,000 liters per kilowatt hour. And as we know, vapor cloud explosions have taken place in homes due to the charging of e-bikes and e-scooters, as well as severe house fires. What this has done in the UK is that the government has actually recognized the potential risks of micro-mobility devices and has announced a call for research into this particular problem. So what do we do about it from an insurance point of view? What we say is prevention is better than cure. And so we have 4S for BESS. First, as you can see, is about selection. And that is about selecting your OEM, your BESS OEM. It's about selecting your insurer, because that can make a substantial difference to the possibility of getting insurance on the site. And lastly, the selection of your EPC contractor. When talking about the site, we need to take into account, obviously, the catastrophe perils that might exist: storm, surge, flood, the proximity of the fire service, whether it's an urban or a rural location, whether there are hydrants on site, whether there is a foul water runoff following fire. Obviously, there's a lot of polluted water. When we're talking about spacing, we're thinking about stacking. Is there stacking on the site? If there is stacking, how is one container protected from another? How is the site laid out? What is the spacing between the enclosures, between the containers? And lastly, we're going to talk about safety. Now, I'm showing you a video here of an electric vehicle being covered by a special fire blanket, which actually puts out the fire. And safety is obviously about good housekeeping on site. That is essential to the good management and practice. We're talking about training of the personnel on the site. We're talking about good management. We're talking about adequate blast barriers, a subject that's coming up following this. We're talking about compliance with regulation. We're talking about taking advice wherever possible. So that then ends my presentation, and that is the end of the video, which shows very little smoke. And if we hadn't cropped it, it would have died down to 0. So thank you very much for listening, and look forward to your questions.
Thank you very much, Charlie, for the presentation and the video. I'm really glad that we overcame those little technical challenges that we had. And next, I'd like to invite Jordan to please unmute yourself, show your video. And just want to say, Carlos, I see that you are answering the questions. The Q&A box is at the bottom of the in the toolbar next to where it says polls and participants. If you click on that, then you'll be able to answer directly to the people. And a lot of the questions start with "Hi, Carlos," so you'll know there for you. Jordan, you're ready? Yeah.
Yes, I must be ready. Up.
Yeah, it's charging up. Yeah, perfect.
Okay.
Okay,
let's go. Thank you, Belen. So, hi again, everybody. So today, I will present you actually 2 special cases that occurred with fire and explosion inside the battery energy storage system. And after, we are going to see one of our solutions to prevent those events to happen. But first of all, in few minutes, just to explain what we do in Stif. So Stif was founded in 1984. We had a turnover this year for 25 million euros for Stif, and for worldwide, we will be around 32 million euros. It's a 105 business. 14 years ago, we decided to go on the safety area because from business, more components for bulk handling, such as buckets, belts. 14 years ago, we decided to go more on explosion protection, but for dust, so filters, silos, everything. And 2 years ago, we have developed a range of products, vent panels, blast panels, deflagration panels, in order to mitigate and reduce the risk of fire and explosion. And of course, we are present worldwide. We have a factory in China. Next year, we will have a factory in USA, but we are present worldwide. So today, concerning the BESS accidents, here on this slide, you have 3 pictures, one for Arizona, one for South Korea, and one for France. Today, I'm going to explain and show you the details about the Arizona accident and the France accident. But before that, just to give you like some ideas about what is the pressure that can an explosion do inside the BESS, I give you some values, a scale of values. So 20 millibar, it corresponds to some broken windows. 140 millibar corresponds to the first little effects and serious damages on the structures. And if you go up to 300 millibar, you have very serious damages to the structures. And for your information, when you have an explosion, the pressure can reach up to 12 bar, so 12,000 millibar. So that's very high kind of pressure. So the first accident, it's Arizona. So it's Arizona. You had a capacity of 2 megawatts, and you had more like 10,000 cells. So here on the slide, you can see how it goes with the time and the different events. But just you need to know that between the first detection of the incident, so at nearly 5 p.m. and the explosion, nearly 3 hours have passed. So at more or less 5 p.m., the detection, the incident was detected. So you had some warning for the firemen to come. They came 1 hour later, more or less, the firemen came. And during 2 hours, they tried to evaluate, they tried to see what they could do to stop the fire to going on, because the fire suppression was discharged earlier. And so 2 hours after their arrival, firemen decided to go to open the front door. So what happened actually is, due to the opening of the front door, oxygen came inside the BSS. And all the toxic and flammable gases that were inside the BSS due to the thermal runaway, the gases moved inside the BSS and they came into contact with the heat of the temperature. That created the explosion actually. And the results were very bad because 8 firemen were injured, including 4 very badly. And of course, the entire BSS was completely destroyed. And just for your information also, the front door of the container was ejected like 20 meters away from the BSS. So you can imagine how much pressure was inside the BSS. And the second one, it occurred in France in 2020. So you can see on the picture, it was a stacked BSS on another one. So to explain you that how it occurred, at 8:32 a.m., the BSS started up, and half an hour later, around 9 o'clock, there was a detection of a battery default. So fire detection alarm was activated. That also activated the inerting system, but it was not enough to reduce and stop the thermal runaway going on. So firemen, they came at around 10:30 p.m. and until the end, around 11:30 p.m., so only 13 hours, they tried to extinguish the fire. So nearly 13 hours to extinguish the fire. So in this case, in the previous case, there was not enough safety equipment. It's the conclusion that was made during that time, not enough safety equipment to protect well the BSS. And I will go further with the safety requirements for the basic protection level you must have on the BSS. So first of all, you must have heat and smoke detection, okay? You must have thermal imaging and fire suppression system. But we have seen on the previous cases, and it's the same in a lot of cases nowadays, and more it will unfortunately going on, because you have more and more BSS on the world. So unfortunately, the probability to have some fires and explosions can happen. So all the techniques and safety equipments that were during the past 2 cases were not enough to reduce or stop the thermal runaway. And it does not include the risk of explosion linked to flammable gases. In the NFPA 855, it says that some jurisdiction requires both preventative measures as well as installation of explosion vents. And that's why in Stif, we have developed a few years ago a range of products in order to mitigate and stop the risk of explosion. So here, just after, I will show you a little video showing what happened with the utilization of our blast panels, named Vigilex arc vents. So I hope you can see clearly the video, because sometimes with the connection, there is a little lag. So here you just have a BSS without any explosion protection devices. We have seen in the previous presentation by Carlos that you can have a lot of kind of safety devices. So what can happen? And what is the function of the vent panel? You will see it very clearly, is in order to release the explosion outside of the BSS. Because if the explosion pressure stays inside, it will blow everything. So that's the main idea of the blast panels, to release the explosion outside. Okay? And in our range of products, we have three different kinds of panels, vent panels. You have the first one is a Vigilex arc vent. So the Vigilex arc vent is without any insulation. You have the arc vent INS Plus. It's a vent panel with an external insulation. And the Vigilex arc vent INS Minus is the vent panel with an internal insulation. Insulation for BSS and for the vent panels is to keep a certain temperature inside the BSS. And some OEM, so original equipment manufacturer of BSS, they want to keep a temperature between 20, 27 degrees, it depends. But you must not exceed more than 40 degrees inside the BSS, because we know that in contact with some gases that can create fire and explosion. So basically, just in few words, so you saw in the movie how it worked, but so the vent panel is a stainless steel membrane cut on three sides with breaking points. And those breaking points are calibrated to resist to a determined pressure called P-stat, static opening pressure. So when you have an explosion and the pressure reaches the P-stat, the static opening pressure, the breaking points will break, like the name, and will open the panel to release the pressure of the explosion outside. Here, I will show you a little movie from one of our tests in Ineris. And you see on the vent panel that it opens on three sides. Only one side is always standing on the vessel that you want to protect, because if not, if it will not be standing on the vessel, it will be thrown away. It can hurt somebody, of course. So you see the idea of to release the explosion pressure outside. And we come to a new product, actually, new product in 2023, named the Express Vent. The Express Vent is a double action product, because we can see it in the next slide. First action we decided to develop is to have a door activated by gas detection. So when you have a detection of the gases inside the BSS, the door will be activated and will open and will evacuate all the toxic and flammable gases outside of the BSS. This is the first action, we name it, sorry, an active solution. And the double action, so the second one would be the explosion venting. Like a normal vent panel, when you have an explosion, you release the pressure outside. So first detection of gas activates the opening of the door that evacuates all the gases outside. And second one, in case of an explosion, you have the vent panel opening with the breaking points to release the pressure outside of the BSS. And we were not the only one to think about this solution. In USA, you have the PNNO, which is the Pacific Northwest National Laboratory, which is actually a subsidiary of the American Energy Ministry. So they thought about a BSS, okay, with doors on the sides and coupled with a gas detection. So if you had a detection of gas inside the BSS, it will open the doors on the sides and evacuate all the toxical and flammable gases outside. So that was just an idea, and nobody produced and made an industrialization about this kind of idea. But the weak point of this idea is, in case of explosion, you don't have anything to release the overpressure outside of the BSS. And just to complete, because one of our customers is Saft, and as Carlos showed on the previous presentation with the blast panel, is one of our customers. It's for us in Stif, it's a complementation, it's an additional of different safety equipment, fire suppression, any kind of what Carlos told us before, and of course, the blast panels. All those elements together can make the perfect safety for your BSS. Thank you for your attention. And as my colleagues said, if you have any questions, do not hesitate. Thank you.
Thank you very much, Jordan. Okay, we have now heard from the three of them, from Jordan, from Charlie, and from Carlos. And I know that there are a number of questions here already for you. And, Carlos has been answering some of them. I'd like to start with a question of my own for the three of you, if I may. The better known chemistries, NNC, it's supposed that the new chemistries, FLP, are better in terms of fire risk. Is this a proven case that, LFP is better, or is it the case that there is just not enough deployment of LFP for us to know whether, the fire risk may be apart? So I hope my question made sense. I just want to understand whether the risk is the same. And I don't know, maybe Charlie, you can open here.
Yes, the risk is not the same, and it's a very technical question, and it's something that our research team are constantly looking at. We do have access to experiments carried out on batteries, and the key thing really is to differentiate between vapor and fire. And the research that we do suggests that there's more research that needs to be done to fully understand these things properly. And every new chemistry that comes in needs to be tested in that same way.
Okay, so I'm just trying to get does it look like LFP is going to be better in terms of fire risk, really, as is this like widely stated, or we just don't know enough?
Well, better for fire, but not so good on vapor, I think is the,
okay.
Yeah.
Okay, sorry, this was my own, this is something that has been bothering me for a while, because the issue with like our technology being considered bankable without, like a lot of deployment, this is like a difficult one to resolve, I think. And another question for Charlie, what is the role of insurers, and when should project managers engage with insurers when they're looking at a battery project?
They should engage very early on, not just because of the chemistry, but also because of the site, and ensuring that it is, the site is actually something that it's possible to actually put a project on. They need to engage about the chemistry to make sure that it's a chemistry that can be insured properly, because insurers generally are getting better at understanding the risk, but they have a much more limited capacity to underwrite now because they realize what the problems are.
Thank you very much, Charlie. So guys, if you want to be bankable, go and talk to your insurance company, because it looks like this is going to be a big part of this. Carlos, you have like about 1 million questions there that said, hi, Carlos, hi, Carlos, hi, Carlos. So let's answer some of this. Should we, for example, let me ask you a few of them, how does the water sprinkler prevent toxic smoke? This has been asked a couple of times.
Okay. Well, firstly, it can avoid the toxic smoke by preventing the fire. So if the water fire suppression system is activated soon enough, we can mitigate or reduce that risk. If this unfortunately has not been possible, the fire suppression system will help to put out the fire before, or have it contained to give to avoid more fire and therefore more smoke.
Okay, shall we continue with the questions?
Yes,
Loic
please.
has another one. What about the containment of spoiled fire water on site? Would it cause environmental issues?
Well, certainly, if we are pouring water in case of a fire, this will be in contact with the chemistry, and that can be toxic. It is the responsibility of the construction company at site who how to do the civil works. So in case that this is needed or used, the water can be contained and we avoid it spilling to water rivers and so on. On our end, what we can provide is a study of what is the what are the elements and the chemistry that is inside of the water after the water suppression system has been activated.
Okay, thank you. And just one more before, we move on. Yes. And we ask a few questions to Jordan because he's very calm there, we need to go for him a little bit. The last question is, what is the maximum temperature in thermal runaway events?
So for lithium LFP, the maximum temperature is about 500 degrees, more or less. And following also your question at the beginning, Belén, about LFP chemistry and NMC chemistry, in our situation, in our experience and how we are designing the systems, we are putting the same fire safety with lithium LFP that what we did with lithium NMC. But in our tests, in terms of radiation, propagation, it's clear that the risk of an uncontrolled fire and the risk of damaging other equipment outside is less with lithium LFP. But you're also right to say that the lithium LFP industry is more recent than the NMC. So a lot of people may say that we don't know if lithium LFP is going to have a lot of problems because the systems have been deployed less. This could be an answer to this. This could be a reasonable doubt, I think maybe a year or 2 years ago. Now there is a important installed base and the fires that we see are less. So we see it both in terms of tests and calculations and also what's happening at the sites.
Thank you very much. So seems like it all adds up with the two of you, going in the same direction. Okay, let's ask a couple of questions to Jordan. One is the question that they've already sent. Elif says, I would like to ask a question about the ventilation of the toxic gases of the battery energy storage system. Maybe you mentioned and I miss it. Is there any filter during the transfer of the toxic gases of the gas directly transferred to the environment? Is the one at the very, very end?
Yeah, so just to answer to this question, actually, our solution is just a vent panel that evacuates the pressure outside, and so the toxic also with the express toxic gases, but there is no filtration in that. Actually, you have some ventilation system inside, of course, the BSS. So for our part, it's just a safety solution, but it does not include some filtration of that. So it's a subject that always can be discussed with the BSS OEM, but no, there is no filtration between the evacuated gases. It's to avoid an explosion and a fire. So we evacuate outside of the BSS and that's it. So it will be maybe more a question for the BSS manufacturer to install a filtration system for that kind of product, but no. So, yeah.
See, even I forget to take my mute off sometimes. So I think this is a follow-up question for you too, but I'm going to open it up because I'm not 100% sure. It's the last one that Olivia sent. And actually, Olivia, Charley's right now answering your question about training, which is an important one, I think. But Olivia also asks, the fire safety measures such as vents have been proven, she would not like to know whether vents have been proven to decrease the risk and allow batteries to have closer distances between each container. So I think, Carlos, you may have to weigh in here. If you have vents, does that change the way that you design the integration of the battery?
For us, we keep the safety limits and the distance between the containers as a minimum distance that we are not. I'm so sorry to be so direct, but we are not flexible on this. We believe that we cannot take these kind of risks, and even if we have the blast panels, which I think that is what they mean, we are still keeping the same distance between the containers. Yes, this can reduce the risk, but not completely, and some systems may fail. And I don't know if Jordan will have maybe also something to add here.
Yeah, actually, the idea to have the blast panel, they are put on the roof of the BSS in order to release the pressure upwards, you know. But it's like Carlos says, it's not because you have vent panels that you must be close, very close, one BSS to another one. It's always good to have a certain distance between two BSS, because in case of fire, even if you have all the kind of protection, it's always good to have some distance security, because we do not want the flame and the explosion to spread into another one that can lead to another kind of explosion, etc. So I think it's always good, yeah, to have a certain distances between two BSS, but that's the OEM manufacturers that will decide with their customer, of course, for the implementation. Yeah.
Again, thank you very much, Jordan and Carlos. There are a number of questions open. Is there any specifically that you'd like to answer? You know, maybe take a look, because there is a few still, I think. And I can see, Charlie, that you're answering some of the questions that were there for you, but if there is any others. And this standard is mentioned a lot here in the questions. The PGS 37, you know, there is, well, actually, Luis Sierra has asked a couple of them. The fire protection PGS 37. Do you guys can you tell us what it is and why, how it changes things?
Well, on my end, that's something I will need to ask to our fire expert on the future certification for next year. So I can come back to this one later if this is possible.
Jordan and Charlie, do you have any comments here? It's okay if you don't. You know, I just wonder, you know, because it was mentioned a couple of times.
Not that much about this subject.
No.
Okay.
I can get an answer for it, but I can't give you an answer now.
Right, that's fine. That's fine. It does happen like this, by the way. There is no one person that knows absolutely everything about any topic, you know, which is why I think these webinars are so important, so that you can hear experts in different areas, you know, that can give you the answers, and you know who to ask, you know, when you have the questions. So that's fine. So any last questions, Carlos, that you'd like to answer, or Jordan or Charlie, live?
Yeah, I saw one question from Athanasios Vassiliadis Sakatias.
Yep.
There is another one, but the question was, is it ever possible to stack battery containers, especially since deflagration panels are most often placed on the top side of the container? And in that case, what additional measures should be considered? So to answer to that question, I say in Stif, like we are a safety manufacturer of equipment, we don't think stackable containers are the best solutions for that. But in the case you have already stackable containers, we have also another solution. I don't know, Belen, if I can just share my screen 2 seconds to show the product I was going to show.
All right, well, 2 seconds. We'll just take 1 more minute. And Carlos, you prepare a question, and then after that it will be done.
Okay, I don't know if you can see my screen.
Yeah, you can.
Okay. And so we have developed also a solution named VigiSpace. So it's like deflagration product. So in the case of you cannot put the vent panel on the roof of the BSS, you can put it on the sides of the BSS, and that way, when there is an explosion, the panel will touch the VigiSpace and will guide the pressure and the explosion upwards in a safe area. So that's one of the solutions we can offer, actually, an additional offer. In that case, a specific case, the person was asking me. Yeah.
Okay, thank you very much. And actually, this is a great question to end, I think, that Carlos has just marked here. What do you believe will be the greatest barrier of entry to making battery energy storage systems bankable in the next 5 years? So I open this up to the three of you, and then we'll close. So just keep your answers relatively short. And Carlos, you start.
I'm sure that Charlie will have something to add here. Regardless of the or on top of the safety, what is the most important aspect to have the project bankable is on performance warranties. What does the manufacturer or even the construction company warranty that the system is going to have a certain performance during the next 5, 10, 15 years, and also what is the availability. If you have a safer device, you will have a higher also availability. And Charlie, I'm sure you will have what to add.
Charlie, you've been mentioned, so go ahead.
So yes, good question. So what we do as a company is to provide degradation extended warranties, which underpin the balance sheet of OEMs manufacturing cells, or indeed battery packs or modules, or indeed the OEM manufacturer himself, the container manufacturer, which allows, because it's A-rated paper, it allows banks to lend money on those systems, which they wouldn't normally do.
Jordan, any last words of wisdom?
Well, it's a little resume of what my partners today I'd say, but yeah, it's for us. It's like you must have all, not just one equipment, safe equipment, but you must have an additional items that together will work on the safety of making the BESS safe and reliable, and with a high lifetime, lifetime in the future. So I think, yeah, it's about that, about the additional items that you can put inside your BESS to be safe in the future.
Excellent. Well, thank you very much, Charlie. Thank you very much, Carlos, and thank you very much, Jordan. This has been an excellent webinar. I think we've all learned a great deal, and also not only you have like the chance to see this information again when you want, you also have names of people who you can contact when you have these questions, and when you want to engage in commercial partnerships. So just a reminder that we are organizing this webinar and others on the back of the event that we have in Toledo in March 29th and 30th, and we hope that you can join us, because there is going to be such a commercial explosion, of storage systems in Spain, that I think these are some of the issues, that we have to resolve in the country. And without further ado, thank you very much once again, and see you next time. Thank you.
Thank you.
Thank you.